Back to another lecture. In the last lecture, we have discussed some important conclusions from waves. In this lecture, we are going to apply those concepts to get to the final answers to the past paper questions from waves. Let's get started. Which of the following statements about the speed of wave on a string is correct? Speed depends on frequency, on tension in a string, on mass per unit length of the string. Formula to calculate the speed of wave through a string is under root tension in a string over mass per unit length. So it is obvious that option D is the correct option. Which of the following options could represent the time period of the wave? Time period is the time in which one wave travels through one point, right? So this is what we call one wavelength, length of one wave. The distance from trough to trough is called one wavelength, not mentioned here. The distance from crust to crust is also called one wavelength. So the time to travel this distance will be the time period. So given that the time is on x-axis, option C should be the correct option. If a wave has a frequency of 10 Hz, then the time period of wave will be, frequency is given, we are to calculate time period. Time period is the inverse of frequency. It is 1 over 10, that is 0.1 seconds. One wave is taking 0.1 seconds and therefore 10 waves are taking 1 second to pass through a point. And frequency is the number of waves passing through a point in 1 second. Then, which two tuning forks of nearly when two tuning forks of nearly the same frequencies are sounded together, a note of alternately increasing and decreasing intensity will be heard. Based on the given description, the note is called. We know that whenever two waves are traveling through the same medium in the same direction with slight difference in their frequencies, we observe beat, with number of beats per second equals the difference in the frequencies. Then the option that shows the condition used by Laplace for correcting the velocity of sound is, Newton gave his final answer, right? Considering that the sound propagates following the isothermal process. Then the calculated answer was not similar to that of the experimentally observed. Then Laplace made the correction and he said that the process is not isothermal, it is adiabatic, right? And he introduced another term that is gamma, and he finally calculated the value that was 333 meters per second, right? And experimentally the value was 332 meters per second. So the Laplace made correction in the process. He said it is adiabatic process and not isothermal, and both of them calculated the speed of sound in air at 0 degree centigrade. So the correct option is adiabatic thermodynamic process, and the medium used was gas because they calculated for air. When a listener moves away from stationary source of sound, then for the listener, apparent change in the pitch and frequency of sound is. So let's just see this question in a while. The options are not here. Which of the following lines represents example of a transverse and a longitudinal wave? We have studied two kinds of wave, right? Depending on the direction of propagation of wave and the oscillation of medium particle. And we concluded that whenever the medium particle is oscillating along the direction of propagation of wave, these kind of waves are longitudinal. And when they are oscillating perpendicular to the propagation of wave, then these waves are transverse waves. And then we discussed a few examples from each longitudinal and then transverse waves. We know that water ripples are transverse waves, right? So option A and D both could be correct, right? Because sound is not a transverse wave, it is longitudinal wave. Air particles move to and flow in the medium, right? Now, is light a longitudinal wave? No, light is the part of electromagnetic spectrum. They all are transverse waves. It is wrong. Sound is a longitudinal wave, as I mentioned just. Option D should be the correct option. When a swimmer goes deeper into the swimming pool, temperature of water decreases. As a result, speed of sound will. In other words, आपसे पूछें जब temperature कम होता है तो sound की speed पे क्या फर्क पड़ता है? We have discussed an equation which says speed of sound at given temperature plus 0.61 for every single degree centigrade increase in temperature. And we concluded that with every 1 degree centigrade increase in temperature, speed of sound decreases 0.61 meters per second. Speed of sound increases 0.61 meters per second, right? So with the decrease in temperature, speed of sound should decrease. Then the place where compressions of one wave combining with the rarefaction of another wave to cancel each other is called nodes. We have studied in standing waves or even in the superposition, general superposition of waves. And we say that at points जहाँ पर एक wave का crest दूसरे के trough से मिल जाए या एक का rarefaction दूसरे के compression से मिल जाए, उस point पे resultant displacement of medium particle becomes zero, given that the amplitude of both the waves were equal, right? And the medium particle stays at the mean position. In other words, these are the points that we refer to as node points. In the below diagram, frequency of wave will be equal in all cases, greatest in one loop, greatest in two loop, greatest in three loop. Let's just see. It is not obvious from this figure कि किसमें frequency ज़्यादा होगी किसमें कम, लेकिन it is obvious कि किसमें wavelength ज़्यादा है किसमें wavelength कम. Let's just get to the conclusion. Wavelength का क्या ट्रेंड है इसमें and then उसको रेसिप्रोकेट कर देंगे और हमें frequency का ट्रेंड पता चल जाएगा, because we know that wavelength and frequency are inversely related to each other given that the frequency of wave is given that the velocity of wave is constant, right? So in this case, if I say that the length of this string is 1 meter, so in this case half of the wave, right, is occupying this total length, so we'd say that wavelength is 2 meters, ठीक, because half wave आ रही है 1 meters में. In this case we'd say 1 meter में एक complete wave आ रही है, इसका मतलब है wavelength is also 1 meter, जबकि इस case में wavelength further reduce हो रही है. In other words, we'd say that इस case में wavelength सबसे ज्यादा है, इसमें wavelength सबसे कम है, vice versa. इसमें frequency सबसे ज्यादा है और इसमें frequency सबसे कम है. So आपसे कहा था frequency of the wave will be greatest in three loops, right? Then, when a listener moves away from a stationary source of sound, then for the listener, apparent change in the pitch and frequency of sound is source is moving away from the listener. जब source away move कर रही होती है listener से, तो Doppler's effect में हमने conclude किया था pitch of sound decrease करती है, right? And pitch is directly related to the frequency. जब एक increase करता है तो दूसरा भी increase करता है, जब एक decrease करता है तो दूसरा भी उसी same trick को follow करता है. इसका मतलब है ऑप्शन बी और ऑप्शन सी तो आउट ऑफ क्वेश्चन है, ए और डी में से हमें देखना था. जब सोर्स क्लोजर आ रही होती है ऑब्जर्वर के, तो पिच और फ्रीक्वेंसी दोनों इंक्रीज हो जाते हैं, और जब सोर्स अवे मूव कर रही होती है तो पिच और फ्रीक्वेंसी दोनों डिक्रीज हो जाते हैं, राइट? सोर्स को मैं अवे मूव करवाता कंसिडर करूं या मैं कहूं कि सोर्स स्टेशनरी, ऑब्जर्वर इज मूविंग अवे फ्रॉम स्टेशनरी सोर्स, राइट? आइदर वे दोनों डिक्रीज हो जाएंगे. ऑप्शन ए इज द करेक्ट ऑप्शन. Resultant displacement of any point due to the sum of displacements of two or more waves is called. This is the principle of superposition. This is the simple statement of principle of superposition. Whenever two or more waves encounter in the same medium, तो medium particle की resultant displacement depend करेगी multiple waves की वजह से particle में कितनी displacement आएगी उस पर, right? Which of the following factors affect the speed of sound in air? Again, इसके लिए we have seen an equation और इसको हमने पिछली वीडियो में भी थोड़ा डिस्कस किया था. Speed of sound के लिए Laplace ने जो corrected formula दिया था, it was this one. And then we concluded density और speed inversely related है. Density अगर आप decrease करेंगे तो speed of sound उस medium की increase हो जाएगी, right? Temperature पर भी depend करता है, अभी हमने ऊपर देख लिया. With every 1 degree centigrade, 0.61 meters per second का change आ रहा था. However, we concluded that even though you see this pressure here in this equation, लेकिन pressure जब भी आप change करवाते हैं medium का, consequently density में भी फर्क आता है. They cancel out each other, and hence there is no effect due to the change in pressure in the speed of sound. Right? तो कौन affect करता है? Density and temperature. 1 and 3. Option B is the correct option. In the phenomena of Doppler's effect, when a source of sound moves towards a stationary listener, जब source listener की तरफ आ रही है, तो अभी हम पढ़ के गए थे जब अवेज आती है तो फ्रीक्वेंसी और पिच इंक्रीज हो जाती है, डिक्रीज हो जाती है। अब जब सोर्स लिसनर की तरफ आ रही तो फ्रीक्वेंसी एंड पिच इंक्रीज हो जाएगी, बट ये आपसे पूछ रहे हैं क्या डिक्रीज हो रहा है। और मुझे पता है अगर फ्रीक्वेंसी इंक्रीज हो रही है तो इट इज इनवर्सली रिलेटेड टू दी वेवलेंथ, राइट? वेवलेंथ शुड डिक्रीज, wavelength of sound should decrease, right? Because the speed of sound is constant क्योंकि मीडियम चेंज नहीं हुआ, फ्रीक्वेंसी और पिच तो इंक्रीज हो रहे हैं, it is the wavelength which should decrease. If 20 sound waves pass from a point of a medium in 2 seconds with the velocity of 20 meters per second, then the wavelength we need to calculate. Velocity is given 20 meters per second. अगर हमें frequency पता चल जाए तो we can calculate the final answer because lambda equals v over f, since v equals f lambda, right? Velocity is 20. How about this frequency? आपसे कह रहे हैं 2 सेकंड में 20 वेव्स पास हो रही हैं। फ्रीक्वेंसी क्या होती है? फ्रीक्वेंसी इज नंबर ऑफ वेव्स पासिंग थ्रू अ पॉइंट इन 1 सेकंड। अगर 2 सेकंड में 20 वेव्स पास हो रही हैं तो इट इज ऑब्वियस कि 1 सेकंड में 10 वेव्स पास होंगी। इसका मतलब है फ्रीक्वेंसी इज 10 हर्ट्ज। जस्ट पुट इन दीज वैल्यूज, 20 over 10 it is 2, and meters because we have put in this velocity in meters per second and not in centimeters per second. So B should be the correct answer. Which of the following properties of sound is affected by the change in temperature of the atmosphere? Temperature change होने से क्या फर्क पड़ता है? We just discussed with this equation as well. With the change in temperature, speed of sound decreases, right? Frequency and velocity does not change because frequency और wavelength में जो apparent perceived by the observer है उसमें फर्क आता है due to the relative motion of source and observer, right? या अगर वो relative motion का जिक्र करते तो फिर हम frequency और wavelength की तरफ देखते। Otherwise, with the change in temperature, velocity of sound changes without any shift in frequency and wave. So option A should be the correct option. Then, in a stationary wave, velocity of particles of medium at the nodes is, node को हम define ही कैसे करते थे? हम कहते थे nodes are the points in the medium where the resultant displacement of the particle is zero, where the displacement of particle in the first place is zero, right? These are the points जो move नहीं करते, they appear to be stationary. तो in other words, nodes पर medium के particle की velocity क्या होती है? It becomes zero. When a fire brigade approaches to a stationary listener, frequency of sound of its siren received by the listener is, consider करें एक sound source which is approaching the stationary listener. तो of course listener के लिए sound की pitch और frequency दोनों increase हो जाएगी, right? It varies but not unpredictably. It remains the same. No, it does not. There is a shift. Doppler's effect में हमने पढ़ा है. It becomes less than the frequency of original sound. होता ये correct option. Had the source been moving away from the stationary observer. इस केस में क्योंकि it is moving closer to the listener, तो frequency becomes greater than the frequency of original sound. When two or more waves overlap at the same time, the resultant wave will be the sum of individual wave. This principle is, again, अभी ऊपर हमने ये MCQ देखा, it is superposition. Then, in the Doppler's effect, if the source of sound and the listener both are at rest, then the frequency of sound heard by the listener will be. Doppler's effect को basic define ही हम कैसे करते थे? हम कहते थे the apparent shift in frequency due to the relative motion of source and observer. जब वो आपसे कह रहे हैं दोनों रेस्ट पर हैं, इसका मतलब है देयर इज नो रिलेटिव मोशन, इसका मतलब है देयर विल बी नो शिफ्ट इन दी फ्रीक्वेंसी, राइट? विल नॉट से कि फ्रीक्वेंसी जीरो हो जाएगी, फ्रीक्वेंसी अभी भी है साउंड की कुछ ना कुछ, बट उसका शिफ्ट जीरो हो गया. In other words, apparent frequency is equals to the actual frequency of the source. In the Doppler's effect, which of the following does not change in case of moving listener and source at rest? Source rest पर है, listener move कर रहा है. They did not mention कि closer move कर रहा है या away, इसीलिए options में increasing और decreasing के terms में नहीं है, बस generally आपसे पूछ रहे हैं. Doppler's effect से apparent shift आता था frequency में and consequently in the wavelength. Wave की speed पर कोई फर्क नहीं था पड़ता, right? So correct option should be D, that is 1 and 3. These were the multiple choice questions from the past paper. Now let's get started with the constructed response questions. It says a source generates transverse waves of frequency 2000 Hertz. Frequency is 2000 Hertz. Then the distance between 11 consecutive nodes is 80 centimeters. 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the waves. Let's just draw them. आपसे कह रहे हैं 11 consecutive nodes के दरमियान जो total distance है it is 80 centimeters. We can take it to be 0.8 meters, right? आपसे कह रहे हैं ट्रांसवर्स वेव की स्पीड कैलकुलेट करें, ठीक है? इफ वी आर टू कैलकुलेट स्पीड तो हमें किसी तरह वेवलेंथ पता चल जाती, तो हम v इक्वल्स एफ लैम्डा अप्लाई करके स्पीड कैलकुलेट कर लेते, राइट? फ्रीक्वेंसी इज 2000 हर्ट्ज, वेवलेंथ की वैल्यू प्लेस करेंगे एंड विल गेट टू द फाइनल आंसर. Wavelength directly नहीं given, लेकिन they've provided us with enough information to calculate the wavelength. See, यहाँ से यहाँ तक it makes one wave, two waves, three waves, four waves, and finally five waves. अगर 5 waves की length is 0.8 meters, तो what should be the wavelength? That is length of one wave. 0.8 divided by 5. It is 0.16 meters. So let's just put in here 0.16 multiplied by the frequency. It gives you 320 meters per second. Then two organ pipes P and Q sound at their fundamental frequency. Pipe P is closed at one end. It is closed at one end and open at the other. And pipe Q is open at both the ends. It is open at both the ends. Now, sketch diagrams to represent the mode of vibration in both cases. Present the expression for the wavelength and frequency for each mode. The fundamental mode, when the pipe is closed at one end and open at the other is, we know जब भी एक एंड हमारे पास क्लोज होता है उस एंड पे मीडियम पार्टिकल्स आर बाउंड, यानी वहां पर हमेशा नोड बनता है. जो एंड ओपन होता है वहां पे पार्टिकल्स आर फ्री टू मूव, वहां पर हमेशा एंटी नोड बनता है, राइट? द वेरी बेसिक केस फॉर वन नोड एंड वन एंटी नोड इज दिस वन, राइट? दिस इज द डायग्राम यू आर टू स्केच. ठीक, इसी तरह जब वो आपसे कहते हैं फॉर दी पाइप विच इज ओपन एट बोथ द एंड्स, तो क्योंकि दोनों एंड से ओपन है तो दोनों एंड्स पर एंटी नोड्स बनने चाहिए. दिस इज द first harmonic while keeping anti nodes at both the ends. Diagrams हो गई. They are asking you to write down the wavelength. If this is the length of the medium and we take it to be L, right? So हम कैसे लिखेंगे? Length किसके बराबर आ रही है? Quarter the wavelength, because wavelength complete कहीं ऐसे जाकर होती आगे, right? So we'll take L equals lambda by 4. आपसे lambda पूछा है, so you'll just write lambda equals 4L. ठीक. How do we calculate frequency? Frequency is velocity over wavelength. Now that we know the wavelength, we can write it V over 4L. How do we write wavelength in this case? Again, distance from one antinode to node. This is 1 times lambda by 4, another times lambda by 4. This is length is 2 times lambda by 4. Or we can write it as length is lambda by 2, or 2 times length equals lambda. Now that we know lambda, just put it in the equation and you will get to know the frequency. Frequency is V over lambda, so it is V over 2L. अगर आपसे कहते हैं फर्स्ट ओवरटोन के बारे में, तो फिर आप इसका नेक्स्ट पॉसिबल केस बनाते हैं यहाँ तक, राइट? जिसमें आपके पास दो नोड्स और दो एंटी नोड्स आ जाते हैं, सो ऑन. Then write any 5 properties of stationary waves. Stationary waves के हम ये 3 बेसिक केसेस पढ़ते थे ना, जब दोनों एंड से क्लोज है, दोनों से ओपन है, एक पर क्लोज है और एक से ओपन है। इसमें हम कुछ बेसिक टर्मिनोलॉजीज पढ़ते थे, नोड्स हमने स्टेशनरी वेव्स में ही पढ़े थे। फिर हम कहते थे इसमें एनर्जी का कॉन्सेप्ट ट्रैवलिंग और प्रोग्रेसिव वेव से डिफरेंट होता है। इसमें कुछ पॉइंट्स ऐसे होते हैं जिसमें मीडियम पार्टिकल्स जो हैं वो डिस्प्लेस नहीं होते, उनका एम्पलीट्यूड जीरो रहता है, राइट। उसके बेसिस पे वर्ड करते हैं जरा अपने आंसर को। राइट एनी 5 प्रॉपर्टीज ऑफ स्टेशनरी वेव्स। स्टेशनरी वेव्स में एनर्जी रिमेन्स स्टेशनरी। कहाँ स्टेशनरी? एनर्जी रिमेन्स स्टेशनरी बिटवीन एवरी टू नोड्स, राइट। नोड्स के अंदर ही इट कीप्स ऑन ऑसिलेटिंग। मीन पोजीशन के करीब किनेटिक मैक्सिमम हो जाती है, पोटेंशियल मिनिमम। एक्सट्रीम्स पर पोटेंशियल मैक्सिमम हो जाती है, किनेटिक मिनिमम। सो इट कीप्स ऑन स्विचिंग बिटवीन किनेटिक एंड पोटेंशियल, बट इट रिमेन्स स्टेशनरी बिटवीन दी नोड्स। Then it is the series of alternating nodes and antinodes. ये भी हम पीछे देख चुके हैं. It has multiple nodes and antinodes. Nodes are the points जिसपे medium particle की displacement zero हो जाती है, और antinodes पर इसकी कुछ ना कुछ displacement होती है, like maximum displacement होती है. Then amplitude and velocity changes periodically. एक बार medium particle will move at one side of the equilibrium position and then to the other side of the equilibrium position, and therefore consequently velocity changes its direction as well. Then at nodes displacement of particles is zero, as I mentioned, and at antinodes displacement of particles is maximum. Then verify that the modulus of elasticity and pressure has the same dimension. Pressure के लिए dimension क्या है? Pressure is force per unit area. So we can write it as Newton per meter square. Newtons को भी we can write as kilogram into meters per second square, and ये वाला meters square as it is. Let's just simplify this equation to the most we can. Kilograms per meters into second square. Dimensions का पूछ रहे हैं. In order to represent kilogram, that is the unit of mass, we represent capital M in dimensions. To represent meter, we have capital L. To represent second, we have T. This is the dimension for pressure. This same should be the dimension of modulus of elasticity, right? Either we say that modulus of elasticity is how much stress is applied over what was the strain, right? And stress का अपना unit भी क्या होता है? It is meters per newtons per meter square. Strain is a dimensionless physical quantity. So again मेरे पास इसके लिए dimension क्या आ जाती है? Meters per L T square, right? Or we can also do this because इस chapter में हमने modulus of elasticity के लिए एक और general equation पढ़ी ना, हमने पढ़ा था velocity is under root gamma E, that is modulus of elasticity, over density. तो मैं square ले लूं अगर दोनों sides पे, velocity का square is gamma E over density. root cancel हो गया square से, right, on the right side of the equation. and gamma को मैंने exclude इसलिए कर दिया because gamma is again a dimensionless quantity, एक number होता है, right. दो सेम टाइप ऑफ क्वांटिटीज का रेशियो मोलर स्पेसिफिक हीट्स का, ठीक। अब अगर मैं मॉड्यूलस ऑफ इलास्टिसिटी के लिए इक्वेशन बनाना चाहती हूँ तो इट शुड बी v स्क्वायर इनटू डेंसिटी। v इज द वेलोसिटी, इसकी डिमेंशन क्या होती है? lt माइनस वन, ठीक। ये स्क्वायर एज इट इज। रॉ इज डेंसिटी, डेंसिटी इज मास पर यूनिट वॉल्यूम, राइट। मास के लिए वी यूज कैपिटल M, यूनिट वॉल्यूम it is L cube. Next what we can do is it is L square, इस square को अंदर ले आते हैं and इसको we can write it T square, ठीक। and then this M and this L cube as it is, इस square से ये square cancel, we are left with L raised to the power 1. See, the final unit is M L T square, or we can write it as M L minus 1 T minus 2. Same goes here. We can write it as M L minus 1 T minus 2 and then enclose it in the square bracket following the convention for dimensions. Then in the given diagram, an organ pipe that is open at one end has the length of 0.762 meters. If the velocity of sound is 335.28 meters per second, then which harmonic is the second overtone? We know that second overtone का मतलब क्या होता है? Second overtone is third harmonic, right? The harmonic that corresponds to the third possible value of n. इस केस में देख लेते हैं, while discussing all three cases for stationary waves, we discussed that whenever the medium is open at one end and closed at the other, जो possible values n की हैं, they are the odd integers 1, 3, 5, 7, 9 and so on. General formula for wavelength was क्योंकि L equals n lambda by 4, तो हम इसको जनरलाइज कर देते थे, lambda is 4L over n, right? अब आपसे क्या कह रहे हैं? आपसे कह रहे हैं find the value of second overtone. Second overtone यानी n की थर्ड वैल्यू, राइट? थर्ड हार्मोनिक कहूँ या सेकेंड ओवरटोन कहूँ, एक ही बात होती है. इसके लिए वी नीड टू कैलकुलेट. और आपसे कहा है हार्मोनिक निकालें, तो वेवलेंथ पर नहीं रुकते, डायरेक्टली फ्रीक्वेंसी के लिए इक्वेशन बना लेते हैं. Frequency is nothing but velocity over wavelength, so we can write it velocity over this wavelength, right? ये n ऊपर चला गया. आपसे कहा है second overtone यानी third harmonic, third value of n is 5. Let's just place it here. n की जगह 5. Velocity is given to be 335.284 in the length of the pipe as it is 0.762, right? Let's just put in these values to the calculator and see the final answer. It comes out to be 550 hertz. Then write any 5 characteristics of progressive waves. Progressive waves are traveling waves, right? जिसमें आप continuous medium में disturbance create करते हैं और एक wave जो है train of pulses travel करती हुई जाती है. ठीक? Let's just see how do we list characteristics of progressive waves. No particle is throughout at rest, unlike standing waves. Standing waves में कुछ nodes होते थे हमारे पास, वो points जिस पे medium के particle rest पर होते थे, वो displace नहीं होते थे mean position पे. Progressive wave में there is no such point as nodes. हर medium particle will be subjected to the displacement from the mean position. Then it is the result of continuous disturbance in the medium because train of pulses travel करती है. All particles vibrate with identical amplitude depending on what was the amplitude of the frequency जो subject किया जा रहा है medium को. Energy flows in the direction of wave propagation. Stationary waves में हम क्या पढ़ते थे? दो nodes के दरमियान energy is stationary. But in the case of progressive waves, energy flows from one point to another, that is from the source to the direction of propagation of wave, and phase of each particle varies from 0 to 260 per cycle. हर cycle में medium particle will oscillate and the phase will vary from 0 to 2 pi radians. Then what is interference of sound wave? Identify the type of interference in the given diagram. Interference क्या होती है? Whenever two or more waves encounter in same medium having same frequency and moving in same direction, the resultant phenomena is called interference. फिर हम पढ़ते हैं interference दो तरह की हो सकती है depending on how these waves are encountering. If they are encountering so that their crusts are falling at the same point and their troughs are falling at the same point, we say that this type of interference is called constructive interference. Resultant amplitude will increase, right? And then if they are encountering so that the crust of one wave coincides with the trough of the other, we label it as destructive interference. And then we say कि resultant जो displacement होगी wave की, it would be the difference of the individual displacements. Then prove that the speed of sound varies with the square root of absolute temperature. This is the exact derivation in your learning objectives and in your textbook as well. Let's just see how to go about with this final result. Starting with the general equation, We know that the speed of sound varies inversely with the density, right? So we'll just write it this way: density at t degree, density at 0 degree. Speed of sound at 0 degree, speed of sound at t degree. Okay, let's just invert it. Speed of sound at t degree over 0 degree, and density at 0 degree over density at t degree centigrade. Let's just label it as equation 1, and we know जब हम generally gases की बात करें, because these equations were derived for air, right? Generally जब हम gases की बात करते हैं या बल्कि किसी भी medium की बात करें, हमें पता है medium particle with the change of temperature, जो medium है, it experiences expansion, right? Thermal expansion. और हम कहते हैं final volume at temperature T will be related to the initial volume with this equation, where this T is the temperature and this beta is the coefficient of thermal expansion. When we talk about air as a medium, gases के लिए beta की value is fixed, which is 1 over 273. So we can rewrite this equation specifically for gases to be V naught 1 plus T over 273. This is the equation for Vt, right? And do not get confused here. This is the velocity and this right here is the volume, right? Let's just relate this volume in terms of density. We know that density is mass per unit volume. So volume is mass per density, right? Volume at T degree centigrade can be rewritten as mass divided by density at T degree centigrade. Then volume at 0 degree centigrade could be rewritten as mass over density at 0 degree centigrade. Rest as it is. Then, because with the change in temperature, mass of the system does not change, right? So there is no such thing as m naught and mt, just cancel them and then cross multiply it. And we can rewrite it as mu naught equals rho t 1 plus t over 273, right? Now that we know the equation for the density, that is rho naught, let's just put this rho naught in this equation 1 and we can rewrite it as velocity at t degree, velocity at 0 degree equals under root. Replace this rho naught, which is rho t, 1 plus t over 273, and then there's under root rho t in the denominator as well. We can also combine this root here, following the basic property in algebra. This rho t gets cancelled with this rho t and we are left with Vt over V naught equals under root 1 plus T over 273, where this T is the absolute temperature, and this is how we relate that speed of sound varies with the square root of absolute temperature. Then in Doppler's effect, we discussed that we can make use of the shift in frequency to get to the information about if there is a relative motion between source and observer. The same principle is used in radar, sonar, satellites, in redshift and blue shifts from the galaxies. Like we um, transmit the waves of a certain frequency and then we receive the reflected waves, and then depending on the shift in the frequency we conclude if the object is in relative motion or not, and if it is moving, then is it moving towards the observer or is it moving away from the observer. And even with the calculated values or the observed values of the actual and the apparently shifted frequencies, we can calculate the velocity with which the object is moving. We can also calculate the depth of the sea using the same phenomena. Uh, we can detect the aircrafts, their motion, their position using the same phenomena. This is what you are supposed to mention in this equation. Then write one effect of each: pressure, density, and temperature on the speed of sound in a gas. We have studied it in the last lecture, और अभी इसमें भी we discussed in 2 MCQs that pressure की वजह से there is no effect on the speed of sound. Temperature की वजह से if you increase temperature, speed of sound increases because it is related to the under root of the temperature, right? And with the density, if you increase the density, speed of sound decreases because they are inversely related. Then two fishing boats 10 meters apart, this distance is 10 meters, are catching fish in the Arabian Sea. They both are bobbing up and down but return to the same position every 15 seconds, right? Up and down, then return to the same position in every 15 seconds. Yani the time for this is 15 seconds, right? Calculate the speed of wave of the sea water, right? एक क्रस्ट से दूसरे क्रस्ट को पहुंचने में जितना टाइम लगा, it is the time period, right, which is given to be 15 seconds. But in this picture they've given us the distance between this, right? It is 10 meters, but we are to put in the distance of one wave, that is one wavelength. It is obvious that यहाँ से लेकर यहाँ तक दो consecutive crust तक it is one wavelength, then it is two wavelengths. So we'd say that two wavelengths are 10 meters. तो फिर हम क्या लिख सकते हैं? Wavelength is 5 meters. Now that we know time period and wavelength, we can easily calculate the speed of the waves. How? So v equals f lambda, right? Either we take the inverse of this time period and we put it in this equation, या फिर हमें directly ये पता है कि frequency is 1 over t, so we can rewrite this equation इस तरह से. Wavelength is 5 meters, time period is 15 seconds. Let's just divide these values and you'll get 1 over 3, which is nothing but 0.33 meters per second. Then again, Doppler's effect is the change in the frequency of a wave for an observer in relation to the source of the wave that is in motion. Source is in motion. Analyze the working of radar and sonar on the basis of Doppler's effect. Same effect. Source will emit the radiations. Source will emit the waves at a particular frequency. These waves will travel a fixed distance in the given interval of time, will reflect back, and then the detected waves will be observed. उसकी frequency में कोई shift है, इसका मतलब है कि there is a relative motion between source and observer. And उस wave को emit होकर वापस receive होने में कितना time लगा, it would tell us कि कितना distance है between the point जिससे ये waves जो हैं वो strike होकर आ रही हैं. Using the same principle, we can answer this question. Then draw the image of resultant wave of the following two sound waves in the given space. सबसे पहले तो देख लेते हैं, we have multiple waves passing through the same medium, right? इसका मतलब है superposition का कोई case है. लेकिन superposition में we have studied multiple cases. Waves traveling with same frequency, waves traveling with different frequency, waves traveling in same direction, waves traveling in opposite direction. Which one is this? Let's just see. It is obvious from this figure that the phase difference between these waves is changing, right? Which makes us think that there is a slight difference between the frequency of these two waves, right? There are points जहाँ पे crust और crust match कर रहा है, but then there are points जहाँ पर crust और trough match कर रहा है, right? Then there are points जहाँ पर trough and trough match कर रहे हैं. जब phase continuously vary कर रहा है, इसका मतलब है कि waves की frequency same नहीं है. तीनों सुपरपोजिशन के केसेस में से एक ही केस था जिसमें फ्रीक्वेंसी में स्लाइट डिफरेंस आता है, इट इज दी बीट्स. और बीट्स की फॉर्मेशन हम कैसे बनाते थे फिगर, वी से कि वो पॉइंट जिसपे एक वेव का क्रस्ट दूसरे के ट्रफ से मीट करता है, उस पॉइंट पे रिजल्टेंट एम्पलीट्यूड 0 हो जाता है. वो पॉइंट जिसपे एक वेव का ट्रफ दूसरे के ट्रफ से मिलता है, उस पॉइंट पर रिजल्टेंट डिस्प्लेसमेंट आती है, ट्रफ बनता है. देन वो पॉइंट्स जिस पर अगेन एक क्रस्ट और एक ट्रफ मीट कर रहा है, अगेन 0 रिजल्टेंट डिस्प्लेसमेंट, सेम डायरेक्शन है, क्रस्ट क्रस्ट या ट्रफ ट्रफ, फिर कुछ मैक्सिमम डिस्प्लेसमेंट आएगी. right? And then again इस point पे एक crust दूसरा trough, they'll cancel out their effects, resultant displacement would be zero, node बन जाएगा इस point पे. Then just trace the figure so that you join these points forming beats. These are the wave packets और इसमें हमें पता है particle की oscillation का amplitude is continuously varying, right? This is what we call beat. Identify the phenomena, of course it is beats, and define it. Whenever two or more waves passing through the same medium in the same direction having slightly different frequencies encounter with each other, the resultant phenomena is called beat. The alternating increase and decrease in the intensity of the sound wave is observed. Discuss Laplace correction to explain that changes in temperature occur under adiabatic condition. We've already discussed it. Newton ने consider किया था process is isothermal, temperature remains same, right? Then Laplace ने assume किया process is not isothermal, it is adiabatic. Compression वाले regions में temperature is greater. Rare fractions वाले regions में temperature is lesser, and process is so quick that there is not enough time for the temperature to evenly get distributed. इसीलिए the product of PV is not constant. This time the product of P V to the power of gamma is constant. And this led us to the final conclusion that velocity equals gamma times pressure over the density and approximate 333 meters per second speed of sound. A singer with a shrill voice sings at 1100 Hz, that is, original frequency is 1100 Hz. Calculate the wavelength of the shrill sound wave. Wavelength calculate करनी है. If the speed of sound is 345 meters per second, right? There is no need for original or apparent because shift का कोई जिक्र नहीं है, right? And there is no relative motion, there is no source or observer. Then V equals F lambda. We are to calculate lambda. Just rearrange this equation so that your unknown becomes the subject of this equation. V over F. Velocity is 345. Frequency is 1100. Just divide these two values to get to the wavelength. It is 0.313 meters. Then given expression shows that the speed of sound is proportional to the square root of the absolute temperature, जो अभी ऊपर इन्होंने prove करने को कहा था. अब आपसे कह रहे हैं show by a mathematical expression that velocity of sound increases by 0.61 meters per second per degree rise in temperature. यानी इस बार they are asking you to get to this final expression starting from this expression, right? And not from the density wala part. Then Vt over V naught, what we can do is, it looks like 1 plus something, let's just call it x raised to the power n. And we can expand it using binomial, which says 1 plus x raised to the power n could be rewritten as 1 plus nx, right? In other words, we can write it as 1 plus, what is n? जो भी power है, which is half. What is x? It is t over 273, right? Then we can write it as 1 plus t over 2 into 273. What is 2 into 273? It is 546, right? It is Vt over V naught. Then what else we could do is, let's just multiply this V naught to this side. It becomes V naught plus V naught t over 546. Since we are to prove कि यहाँ पर 0.61 आ रहा है, right? तो इसको जरा rearrange करके देख लेते हैं. This V naught is the velocity of sound at 0 degrees centigrade, right? And we know that this is nothing but 332 meters per second. So we'll just replace this V naught with 332. this 546 and this t as it is. Let's just simplify them. V naught plus, it is 0.608, which becomes 0.61, and this t as it is. See, with every 1 degree centigrade increase in temperature, speed increases by 0.61 meters per second. Discuss Laplace correction to explain the changes occur in temperature under adiabatic condition. वही जो अभी हमने ऊपर पढ़ा है, रेयर फ्रैक्शन वाले रीजन्स का टेम्परेचर शुड बी लेसर और कंप्रेशन वाले रीजन्स में टेम्परेचर ज्यादा था. According to Newton's hypothesis, during compression and rarefaction, temperature of sound wave remains constant. Newton ने consider किया था कि isothermal है, लिहाजा temperature same रहना चाहिए. Using the above statement, derive the formula for speed of sound through gases, right? क्योंकि he considered the process to be isothermal process की equation PV is constant, right? अगर compressed region को हम consider करें तो in these regions pressure increases. इसका मतलब है pressure would be P plus delta P, where this delta P is the change in pressure, and volume decreases, so V minus delta V is the final volume. Just perform basic multiplication. Just multiply these two values. We have PV minus P del V plus V del P minus del V del P. The product of two very small quantities will give you 0. Then this PV gets cancelled with this PV. We are left with P delta V equals V delta P. Just rearranging this equation, pressure equals delta P over V over delta V. And this is nothing but the modulus of elasticity. So we can rewrite the original equation, which was under root modulus of elasticity over density, to be under root pressure over density. This was the formula derived by Newton, and this led to 280 meters per second final velocity of sound in air. It says consider two fire brigade trucks A and B accelerating after each other with the same speed and generating the sound of same frequency. Nearby, a listener is standing as shown in the given diagram. Listener, two sources of sound. To the listener, which fire brigade truck would appear to have lesser sound frequency? Let's just compare. This is the listener. Let's just compare the wavelengths from both these sources. Is sources को if we compare, the separation between these crusts is less. In other words, wavelength is smaller. Or we can write consequently frequency is greater. In this case, see, waves are stretched, that is wavelength is greater, or we can say frequency is smaller. So to the listener, which fire brigade truck would appear to have lesser sound frequency? Fire brigade B. With reference to the stationary listener, write the mathematical expression of the apparent frequency of sound produced by fire brigade A and fire brigade B. क्योंकि it is the source which is moving, right? तो हमें पता है apparent frequency is original frequency V plus minus observer की velocity V plus minus source की velocity. Since in this case observer is at rest, so u naught is 0. Let's just exclude this from here. Now we need to see दोनों में से किस case में we'll be writing plus and we'll be writing minus. अच्छा, in order to avoid confusion, this A was for apparent, right? Truck A से confuse ना हो तो इसको apparent के लिए F dash use कर देते हैं. How do we write apparent frequency for A and apparent frequency for B? A की frequency is greater, right? Apparent frequency is greater. So how can we get greater final answer from this expression? We'll get greater if this denominator becomes smaller, right? And denominator smaller कब होगा? जब यहाँ पर मेरे पास negative आ जाएगा. So we can write F naught V over V minus US। और in other words हम पहले conclude कर चुके थे, जब भी source towards the observer आती है तो we use negative, जब वो away जाती है तो we use positive। तो उसी basic concept को use करते हुए second के case में we'll keep this positive sign here। These are the two expressions with reference to the stationary listener। Then a source of sound emits frequency of 800 Hertz. Frequency is 800 Hertz while moving at a speed of, source is moving at a speed of 120 meters per second. Calculate the frequency and wavelength of source when it approaches a stationary observer। See, apparent frequency calculate करनी है and apparent wavelength भी। This was the original frequency। Speed of sound in air is given to be 340 meters per second। When the source approaches a stationary observer, इसका मतलब है we'll be taking this equation u v plus uo over v। क्योंकि source is stationary, plus minus us is excluded from the denominator, and क्योंकि source is moving closer to the observer, so frequency should increase. So we have used this plus here, right? Just put in these values. F dash is original frequency 800. This v is the velocity of sound and this u naught is the velocity of observer, right? So we'll be writing 340 plus, okay, let me just correct it here. It says that observer is a stationary and source is moving, right? So let's just rewrite it here. Observer is a stationary, source is moving. So we'll just exclude u naught from the numerator and we'll keep us in the denominator, right? And क्योंकि this source is approaching the stationary observer, तो अभी हमने पढ़ा है denominator में we'll keep minus sign, 340 over 340 minus 120। Put in these values in your calculator and you'll get to know that the shifted frequency is 1236 Hertz. Then again, a radar works to determine the elevation and speed of an airplane using the principle of Doppler's effect। Explain the working of radar with the help of given statement। फिर आप वही कहेंगे कि wave of a suitable frequency is transmitted, it reflects through the aircraft and the reflected wavelength is perceived and analyzed, and then it is compared। If there is a shift in the transmitted and the observed frequency, इसका मतलब है there is a relative motion, and if the frequency, received frequency after the reflection is greater, then we'll say that the aircraft is moving towards the observer. If it is smaller than the original frequency, then the airplane must be moving away from the observer. And depending on the magnitude of the shift, we can comment on the velocity with which the airplane is moving। Then speed of sound is affected by the variation of pressure, temperature, and air density of the atmosphere। Discuss the given statement by showing mathematical relation and how temperature and density of air affect the speed of sound in gases। We've seen it in MCQ and in question as well. No effect due to pressure changes। टेम्परेचर इंक्रीज होने से स्पीड इंक्रीजेस, डेंसिटी इंक्रीज होने से स्पीड डिक्रीजेस। आपसे कह रहे हैं विद द हेल्प ऑफ मैथमेटिकल एक्सप्रेशन, तो लेट्स जस्ट मेंशन इट हियर। Corrected equation Laplace की, this shows that velocity is inversely related to the square root of density। And how do we present temperature? Again, general gas equation से replace करते हैं, P की जगह nRT over V and this raw as it is, and then comment that this velocity is directly related to the under root of temperature। This mathematical expression actually supports your theoretical answer। Then the speed of sound is much higher in solids than that of liquids and gases। Justify this given statement। We've discussed it in the last video। We say that speed is inversely related to the density. लेकिन सॉलिड्स की तो डेंसिटी सबसे ज्यादा होती है, फिर इनमें स्पीड साउंड की सबसे कम होनी चाहिए. बट इट इज एविडेंट फ्रॉम द डेटा दैट साउंड ट्रेवल्स फास्टेस्ट इन दी सॉलिड्स. उसके लिए हम जस्टिफिकेशन ये देते थे कि स्पीड डज नॉट ओनली डिपेंड्स ऑन द डेंसिटी, इट डिपेंड्स ऑन द मॉडुलस ऑफ इलास्टिसिटी एज वेल. राइट, इन सॉलिड्स में डेंसिटी तो ज्यादा होती है, बट सॉलिड्स की मॉडुलस ऑफ इलास्टिसिटी भी ज्यादा होती है, बहुत ज्यादा होती है. राइट, डेंसिटी इंक्रीज होने की वजह से स्पीड डिक्रीज होनी चाहिए, बट इलास्टिसिटी की वजह से स्पीड इंक्रीज होनी चाहिए, क्योंकि द इफेक्ट ऑफ द मॉडुलस ऑफ इलास्टिसिटी इज प्रीडोमिनेंट. इसीलिए साउंड travels fastest in solids, then liquids का modulus of elasticity, and then gases का modulus of elasticity. इसीलिए the sound travels fastest in solids, फिर थोड़ा slow in liquids, and then slowest in gases. Standing waves are formed in an extensible vibrating string as shown in the given diagram. Find the wavelength of the standing wave. ये कौन सा केस है? जो हमने 3 केसेस पढ़े थे. यो medium closed at both ends, open at both ends, closed at one and open at the other. This is the very first case. Medium is closed at both the ends, right? और हम देख रहे हैं that there are nodes at the boundaries. ठीक. This is the very first case, right? Let's just relate it. This is lambda by 2, 2 times lambda by 2, 3 times lambda by 2. So we can say length is 3 times lambda by 2. They've provided you with the length already, right? And we are to calculate lambda. So lambda is 2 times length over 3. Length is 50 centimeters. This 3 as it is. It is 100 over 3, which is 33.3 centimeters, right? Because length हमने centimeters में place किया. If you put it as 0.5 meters, तो फिर you'll get the final answer to be 0.33 meters. Either way does not make any difference. Both the answers are equivalent. Then the last question from the past paper. Two ambulances A and B are moving with velocity 20 meters per second, right? Velocity of ambulance A is 20 meters per second and that of ambulance B is also 20 meters per second. With normal siren frequency of 650 Hz. दोनों की actual frequency is, let's just call them FA, which is 650 Hz, and then we have FB, which is also 650 Hz. Right? Ambulance A moves towards a stationary listener. If this right here is the stationary listener, ambulance A is moving towards the listener, while ambulance B is moving away from the stationary listener. Calculate the frequency of siren heard by the stationary listener from each ambulance. Yani you are to calculate FA dash, that is the apparent frequency from ambulance A, and FB dash, that is apparent frequency from ambulance B. You are to calculate. See, the observer is stationary, the source is moving. So we'll be writing our equation as apparent frequency equals original frequency times speed of sound over speed plus minus speed of source. Kyunki observer is at rest, so we did not write UO here, right? Then the question arises, should we be writing plus here or minus here? We have established so far, जब source is moving towards the observer, यानी जब मैं A के बारे में बात करूंगी, because A was moving towards the observer, so we take minus, and when it is moving away from the observer, तो फिर we take plus here. पहले FA dash निकाल लेते हैं, apparent frequency for the ambulance A. FA dash is F naught, original frequency, that was 650, speed of sound, which is 340 given in the question, then 340 minus source key speed, which is 20. It becomes 650, 340 over 320, and it becomes 690 hertz, right? And it was obvious क्योंकि the source is moving towards the stationary observer, तो जो frequency और pitch है वो increase हो जानी चाहिए थी. If the original was 650, तो answer of course 650 से कुछ greater ही आना चाहिए था. Then how about for the ambulance B? If B dash is 650, 340 over 340 plus 20, right? The only difference is this plus here. And it turns out to be 613.9 hertz, right? Which of course is smaller than 650, which is obvious क्योंकि the source is moving away from the stationary observer, तो frequency or pitch decrease होनी चाहिए. This was all from the past paper questions. Thank you.